Synchronous and asynchronous counters. Synchronous counters. The counters which use clock signal to change their transition are called synchronous counters. All flip-flops in the synchronous counters are triggered by same clock signal. Features. The state output of the previous flip-flop determines the state change of the present flip-flop. We require number of logic gates to implement the synchronous counters. Their operation is fast. Asynchronous counters. The counters in which the change in transition doesn't depend upon the clock signal input is known as asynchronous counters. Features. Another name for asynchronous counters is ripple counters. These are very simple in design. Operation of asynchronous counters is very slow compared to synchronous counters. Asynchronous versus synchronous counters. Synchronous. These are faster than that of ripple counters. Large number of logic gates are required to design. High cost. Synchronous circuits are easy to design. Asynchronous. These are slow in operation. Less number of logic gates required. Low cost. Complex to design. Different types of asynchronous counters. 4-bit asynchronous up counter. 4-bit asynchronous down counter. 3-bit asynchronous up/down counter. Advantages. Asynchronous counters can be easily designed by T flip-flop or D flip-flop. These are also called as ripple counters, and are used in low-speed circuits. They are used as divide by n counters, which divide the input by n, where n is an integer. Disadvantages. Sometimes extra flip-flop may be required for resynchronization. While counting large number of bits, the propagation delay of asynchronous counters is very large. For high clock frequencies, counting errors may occur due to propagation delay. Application of asynchronous counters. These are used for low power applications and low noise emission. These are used in designing asynchronous decade counter. Also used in ring counter and Johnson counter. Different types of synchronous counters. Binary counters, 4-bit synchronous up counter, 4-bit synchronous down counter, 3-bit synchronous up/down counter, loadable counters, BCD counters, ring counters, Johnson counters, etc. Application of synchronous counters. The most common and well-known application of synchronous counters is machine motion control, the process in which the rotary shaft encoders convert the mechanical pulses into electric pulses. These pulses will act as clock input of the up/down counter and will initiate the circuit motion. Thank you.